Hi everyone, I hope you are doing well. So in today's video, I'm actually going to go through the 2018 Specialist Maths Exam 2 Extended Response questions. Like always guys, before I start this video, if you guys want private tutoring in specialist methods, physics or chemistry, you can always email me through this email. Yeah guys, let's smash through this video. Question 1. Consider the function f, where f of x is this. Okay, so it's arcsine function. Determine the maximal domain and the range of f. Okay, so you should know to find the maximal domain for arc or cos, or like arcsine or arccos, is when we take the inside and we want it to be between -1 to negative, let me write it like this, -1 to 1. So, and we solve for x, so it'll be -1 plus 1, hence we just get x squared. Hence that'll be 0, x squared, 2. Okay, now a lot of students might then make that mistake by, okay, to get rid of, to get x, we're going to square root everything. Square root this, and square root this. That's wrong. Be careful. So what this is saying is, imagine the graph of x squared. So let's just draw a graph of x squared. Looks like this. And like that, something like this. And what is it saying is, what values of x is the graph of x squared between 0 to 2. So if I was drawing y equals 0 right over here, and y equals to 2, where is the graph, the green graph, between these values? Well, it's actually between these values from this point to this point, which, if you know, it's very easy to solve. So this will be root 2 here, and hence this will be -√2. So that is your actual x values. So let's write that down. Hence that's your domain. Let's write that down. So hence x is only between -√2 to √2, which we can write nicely, like x is an element, -√2 to √2, and that's it. That is that. That's your domain. Easy. Now, what about your range? Well, you should know that the range for a normal arcsine, for example, and normal, so y equals arcsine of x, has a range where the y values, so your range is between -π/2 to π/2. And let's have a look at this. Well, what can we see? There is a dilation by a factor of 2 parallel to the y-axis. Remember, it says y-axis. It means that it affects the y-axis. So everything in the y values get multiplied by 2. So in other words, we get 2y. Everything gets multiplied by 2. Hence, we get pi and -π. Hence, this here is your range. So we can say that y is an element from -π to pi. Done. Easy. Next question. I know I'm kind of taking my time going through this, but I just want to guys show you how to kind of process every questions, because normally these questions could be used in the first exam, like exam 1, which I want to make sure you guys understand how to approach these kind of questions. Yeah. B. Sketch a graph of f of x on the axis below, labeling any endpoints and the y-intercepts with their coordinates. Nice and easy. So let's actually define the function now, Cas. And so we're saying f of x is 2 arcsine x squared minus 1. And let's sketch this. Perfect. Now what I want to do is I want to scale everything like to my paper. So for example, every square that I see in my paper, like every square scale that I see, I want to make sure it looks the same as my cast. So what I can do is I can exactly draw the points and makes the whatever in the cast be identical to what's in my paper. So let's do that. So go on menu, and let's go window zoom and window settings. From the paper, we can see that the x min is -4, the x max is 4, and every square inch goes by, so every width of each square is 0.5 for your x scale. Same for your y min, so -4, 4, and also 0.5. Enter, and we get this perfect graph. And what do we just do? We just go on view, grid, line grid. So every box right here should be identical to what you're seeing on your paper, and just pretty much draw everything to scale. So let's do that. So I know for a fact that on the second most, we know that it crosses the x-intercept, and we also know at here there's a y-intercept. I know that over here and over here, and now just have to pretty much plot all those points. So nicely go smoothly with this, like that. That's one, and same as this, and that's it. Perfect. So, and we want to label the endpoints. So now it's quite easy to know which endpoints because we have the domain on range. So we know for a fact that this point over here has to be root 2 pi. This one over here has to be negative root 2 pi. This here over here has to be 0, negative pi. Is that all? Perfect. Label the y-intercept with coordinates. Yeah, done. Next question. Find f dash of x for where x is greater than 0, expressing your answer in the form of f dash of x. Okay, not too bad. So let's go on our CAS, and okay, we want to find where the gradient, so f dash of x, so if this is f dash of x, we want it to be where x has to be greater than 0. Enter. Aha, beautiful. Same form as our paper. Let's write that down. So we can say f dash of x is just 4 square root of 2 minus x squared. That's it. Now write down f dash of x for x is less than 0, expressing your answer. This, so same thing, but where x is less than 0. Enter, and we get this. So let's write that down. F dash of x is negative 4 square root of 2 minus x squared. That's it. Next question. The derivative of f dash of x can be expressed in this form, as we saw, over its maximal domain. Find the maximal domain of f dash of x. Okay, let's have a look on the graph. Let's go into this graph, and okay, this is f of x. So how does f dash of x really look like? Well, what we can do is, okay, so we can graph f dash of x. And what do we see? Okay, so as we can see, 0 is not included. So in your domain, 0 is not included. And so they approach the root 2. So for example, this one, x is root 2. They are included, but in the derivative, they are not included. They become asymptotes. And also for the same here. So what we can say is that the domain is from negative root 2 not included to 0 not included. Remember, it's kind of a dead end. It's not continuous pretty much. Yeah, there's no value so for that. And also goes to root 2 not included. Pretty much that is it. So let's write that down. So we can say the domain of f dash is, so negative root 2 to root 2, we can say, excluding 0. We can write it like in this way, or we can also write it as negative root 2 to 0, not included, union 0 to root 2. Also, that's another way you can write it. Both ways work. And it makes sense. Why is 0 not included? I mean, look at these answers over here, what we did. We can see that it says x is greater than 0, this is f dash of x. X is less than 0, this is f dash of x. But they've never said, like, if this is x is greater than 0, this would have, like, if it said x is less or equal to 0, then it makes sense that one of them should, you know, that when you sub in 0 as x equals 0, it exists. But in the overall, it actually gives you the clue that it does not exist. And you can, yeah, have a sketch at it, and that's it. I hope that's right. Find g of x, expressing your answer in the form as a piecewise hybrid function. Okay, well, we already know f dash of x consists of 2, yeah? So g of x is 4 and negative 4. These are your two piecewise, and it's in that form. Great, so we can write it as g of x is equal to, nice piecewise, so, okay, Well, we start from -4. We'll do -4. And what is the domain of -4? We know that -4 is this end of the graph. So it is going to be from -√2, not included, x goes to 0. That's it. And the other one's going to be 4 from 0, x not included √2. Yeah, that looks very good. From what I see on my cast, that looks very nice. Next question. Sketch the graph of g on the axis below. Okay, nice. Well, well, this one here is y equals -4, so it's this over here. It's a straight line, but it's restricted from -√2 to... Now, -√2 is like -1.4, so -1.4 is approximately here, so put an open circle. Make sure you put an open circle. It's not included. To 0, not included. So to 0, not included. There we go. And so from 0 to √2 for y equals 4, so y equals 4 over here. Put an open circle. And √2 is like 1.4 again, so it's approximately over here. And we can nicely put that. That is it. We've just sketched it. Next question. Question 2. State the center in the form xy, where x and y are elements or reals, and state the radius of the circle given by this, where z is a complex number. Very, very nice. You should know that when you get a complex like form, like z minus a minus bi equals some value, let's call it c, what do we know when we have it in this form? Well, imagine that, you know, this negative a, in terms of coordinates, like imagine solving this, like inside z minus a minus b I equals 0, and we're solving for z. So z is equal to a plus bi. Now, this a plus bi is a coordinate. So the coordinate is a and b. This is your center of a circle. Always remember that when you're looking at this form. So in this example, we know that's going to be a. This is going to be the b. So in this form. And this c value is your radius. C in this term is your radius when it's in this form. This is a very quite, it's always in repeats in exams in this form. So yeah, again, just pretty much like solve inside of it. Or you can just very much think, like, you know, the ones that don't have I, like this one's going to be your x coordinate, but like if it's negative, make it positive. And whereas this one, the one that has an I, just think of it, okay, negative b, make it positive, so b. Yeah. So in this form, have a look at this. So what I'm going to do is to find the coordinate of the circle, the center. I'm just going to solve this inside. So let's do that. So z minus 1 plus 2i equals 0. And z is just 1 plus 2i. Hence your coordinate here of the center is just what? It's 1, 2. Nice and easy. And what is your radius? Remember, in this form, your radius is 2. And that's it. These are your two things that you need. Yeah. Next question. Let's see what it's saying. By expressing the circle given by this form in Cartesian form, show that this circle has the same center and radius as this circle given by this. So we want to show that this equation here is a circle that has the same equation as this. Okay, not too bad. Let's do that. So let's write that down. Z plus 1 root 2 z minus I. Now I'm going to let z equal x plus yi. I'm going to sub it in there. So it'll be x plus yi plus 1 root 2 x plus yi minus I, and that's it. And I'm going to just do it simpler, so I'm going to put, so it's going to be x plus 1 plus yi root 2 x plus y minus 1 I. Okay, now we know that what those absolute values mean, it's like the magnitude, so it's going to be the square root, simplified by saying the square root of x plus 1 squared plus y squared. And same thing here, so this is root 2 and square root x squared y minus 1 squared. Now to get rid of those squared, I'm going to square both sides. So square both sides, so square this one and the other side too. So what's going to happen is it will get rid of that square root. Because we were squaring the whole lot of this, this here is going to be 2. Okay, we are nearly done. Now I'm just going to expand these. So it'll be x squared plus 2x plus 1 plus y squared. So 2x squared plus y squared minus 2y plus 1. Hence, x squared plus 2x plus 1 plus y squared, 2x squared plus 2y squared minus 4y plus 2. And see things that can cancel out. So if I bring everything to the right-hand side, let's do that. So I want to make this smaller because it kind of took a lot of space. Okay. So if I take everything, push it to the right-hand side, so it'll be 2x squared plus 2y squared minus 4y plus 2 minus x squared minus 2x minus 1 minus y squared is equal to 0. See things that we can cancel? Well, these here can simplify just to x squared, so we can write that down. That also becomes y squared. These can cancel that to become y squared. I believe there's negative 2x, negative 4y. We also have 2 minus 1, which is plus 1, equals 0. We are nearly done. Now we just need to complete the square for this. So let's do that. So what I'm going to do is I'm going to bunch everything. So x squared minus 2x plus y squared minus 4y plus 1 equals 0. Now I'm going to look at this and think of it as like, we're trying to find the, perfect square for it. It's going to be x squared minus 2x plus 1 minus 1. As you can see, what I just did here, I completed the square for this part over here. And then you remember we have to minus 1. Same thing here. This part over here, let's do that. So it'll be plus y squared, so plus y squared minus 4y plus 4. And we also have to minus 4 plus 1 equals 0. Hence, this is a perfect square, so it's just going to become x minus 1 squared. This one over here just becomes y minus 2 squared. And so this cancel out these negatives, and it's just, we can bring that 4 to the right. And this is a perfect representation of the circle. This is the equation of a circle. What can we see? Well, we can see that the radius will be, the center will be 1, 2. And your radius, the square root of this, is 2. Hence, it is the same equation, hence the same as what we saw on top. So we've expressed it in that form, and we've shown it. Expressed 2. That's it. Graph the circle given by this on the Argand diagram below, labeling intercepts with their vertical axis. Okay, so that's quite easy. So it has a center at 1 and 2. So 1 here and 2 is here, approximately over here. I want to make sure that's nice. Yep. So that's great. And does it go pass through this? Yeah, yeah, nicely like that. Okay. All right, so it passes through that. That's your center, and it has a radius of 2. So if that's 1 here, it'll be over here. And it will be over here. 1, 2, so it'll be over here. 1, 2, it'll be over here. Perfect, and we just draw a circle connecting that all together. Not the best, but all right, like that. Nice. Perfect. Yep, that's enough. Yeah, so graph this on the Argand diagram below, labeling the intercepts. Okay, let's do that. So to find the intercepts, that will be easy. What we're going to do is, okay, we're going to solve first. Well, we don't actually solve for the x-intercepts, because this one we already know is going to be 1, 0. Oh wait, it says labeling the intercepts with the vertical axis. No, vertical, only vertical. Okay, so this and that. Let's do that. So to find out, we're going to have to let x equal 0. So going to our equation, if I let x equal 0, we get, negative 1 squared, which is just 1, plus y minus 2 squared, 4, y minus 2 squared, 3, y minus 2, plus 1 negative root 3. Hence y is equal to 2 plus negative root 3. So that's that. So this point over here will be 2 minus, the coordinate will be 0, 2 minus root 3. This coordinate over here will be 0, 2 plus root 3. I know it's not you can't really see that. Yeah, I need to kind of, oops. You kind of rub that out and really nicely. Okay, so it would be, that point here would be 0, 2 plus root 3. That's it. So have we done everything? Labeling the intercepts with the vertical axis. That's it. Next question. The line given by this intersects the graph given by this in 2 places. Draw the line of this on the diagram in part C. Label the points of intersection with their coordinates. Okay, you should know that this form over here, I mean, look, you can easily, let x equal, let z equal x plus y and take your time with it. But what you can do is just use the perpendicular bisector method. And what does it say? Well, okay, same thing. If I have, say, in this given equation, say we have a line that's z minus a minus bi, or z minus c minus di, something like this. What we do is, again, solve these. So we'll have the coordinate here will be AB. And solve this, and this will be CD. And what we can do is, this is what happens. So imagine that if I was plotting these points, let's say I was plotting these points. Let's say we were plotting these points. This is a faster way to actually draw these lines without, So say A plus B is over here. And say, CD is here. What we do is we draw a line between them, a line segment. And we draw a line that is next. So what is the coordinate of the midpoint? Well, the midpoint's over here. And what we draw is we draw a line that is perpendicular to the line. So a line like this. And hence, this is your equation of the line, this. So let's apply that to what we're going to do here. It will be quicker to draw, pretty much. And it's a very important way to solve questions. So here, I can see that the coordinates are going to be 1, 0 and 3, 0. So if I was looking at this and saying, okay, where is that point? Like, where is it? So we have 1 over here. Let me draw it in a red cross so you can see it. So 1 over here, and that one's here. And so if I was drawing a line segment, what is the midpoint? Well, the midpoint occurs at 2. So imagine drawing at 2, and I'm going to draw a line that is perpendicular to that segment. So the line that is perpendicular would be actually just a straight line. Sorry, I know, just like this, like that. It'll be a straight line that passes through it. And that is your line of this equation. Done. Draw the line of this on the label the point of intersection. Okay, let's do that. Oopsies. All right. Having a look at this, what do we know? It's just a line that is just x equals 2, pretty much. If you just have a look at it, it's a line that's x equals 2. And so if we were trying to find the point of intersection with this graph, what we just do is, okay, at x equal 2, subbing into this equation, let me rub this out, subbing into this equation and solving for the values of y. So what we're going to do is, so it'll be 2 minus 1, which is, again, just 1 squared, which is 1, plus y minus 2 squared, 4. So actually, it's the same equation to these. So pretty much where they occur, if you solve this, it's the same as these. over here. So what happens is, in other words, that these coordinates over here are just the same. So this coordinate over here, this point of intersection, will be just 2, and this point over here, 2 minus root 3, and this point over here, this point of intersection is going to be 2 plus root 3. Hence, that's it. E. Find the area of the minus segment enclosed by the by an arc on the circle given by this and the part of given by this. Okay, we want the minus segment. So let's just take a screenshot of this so I can actually show you which one it is and how to look at it and solve the area. So I'm just going to copy that. I'll come over here. So let's have a look at this. Putting it over here. So we want the area of this segment over here. This is what we call the minus segment, that over here. How do we get the area of that? You should know the formula for calculating an area of a segment. It's very important. It's always been used in exams. I'm telling you right now, every exam too, they've been using the same kind of question type. So the area of a segment, which in this case is going to be, this is make sure you write it in your reference. So r squared theta minus sine theta. That's to find the area. So for example, I wanted to find the area of this segment. What I need to do is, okay, I need to look at the center and draw lines that point to those points. So this point here and this point. To find the area of this, I need to know the angle. This angle, that's your theta. And the radius is the length of this over here. So, let's think. First, let's calculate that radius. Well, okay. What do I know? Well, I know to calculate the radius, what I can do is, I can find this theta and double it to get this. And that will give us the total. So, if I was drawing a right angled triangle over here, what is this length here? What is that length? Well, we know that's 2, and this occurs at 1, so it's just 2 minus 1. So the length of this is 1. So now we want to find the length of this over here. What's that length? Well, we know this point is 2 plus, that's right, so oopsies, oops. Okay, it's 2 plus 2 root 3, oh, sorry, root 3, yep, so that, minus this point over here, which is just 2. So if we minus 2, we just get root 3. Okay. So this over here, this length here is root 3. You should straight away know that this is a perfect right angle, like your exact values in terms of exact. This is a perfect triangle. Like redrawing it over here, this is how it looks. You should straight away know that if you have a length of 1 here, root 3, by using Pythagoras theorem, this has to be 2. You know by your exact values that this here must be pi on 3. Hence, if this here is pi on 3, double it, we get the whole angle. So 2 pi on 3. So we've got the angle. That's great. So your theta, let's write that down, is 2 pi on 3. Great. Now we just, the radius is very easy. We just calculate it right over here. It's 2. So the radius of this over here is just 2. Done. So we know that, and we also know the radius is 2. Putting this all into your formula sheet, you should get the area. Nice and easy. Let's do that. Hence your area is going to be half 2 squared, so it's just 4, which is just 2. Let's write that down. It's 2. Theta is just 2 pi on 3 minus sine theta. So it's sine 2 pi on 3, which is still sine pi on 3. It's the same as sine pi on 3, which is root 3 over 2. We can simplify that to root 3 over 2. Simplifying this much further, we get 4 pi on 3 minus root 3. Hence, this overall is your area, units squared. And that will be it. Perfect. Nice. question 3. Let's have it. Okay, so question 3. Part of the graph of this is shown here. The curve is shown, so the curve is rotated about the y-axis to form a volume of a revolution that is modeled by the model a fountain with length units I in meters. Show that the volume, cubic meters of water in the fountain when it's filled to the depth h is given by this. Okay. So in other words, if imagine that if we were rotating this, it would look like this, something like this. And imagine we were rotating this. This is the fountain. So your depth or your height is your y values. Like this is, you know, the height of the fountain. It's your y values. So that's good to know. And we're rotating it about the y-axis. That's also important. So what we know that the formula for volume, let me write it in a much more, okay. So we know the formula for volume is pi, and because we are rotating it along the y-axis, we need to have y values. Y values over here and here. Well, of course, the fountain's going to start at 0. Imagine it starts here. Well, it doesn't have anything, and it's going to move at some height. We don't know, so we'll call that height. We call it h, height. And so we need to get the x squared. Remember, if it's dy, so we need to get the x squared here. And we need to calculate that x squared. Now that's easy because if you look at over here, let's solve for x squared. So if I multiply both sides by half, we get 2y square root 4x squared minus 1. If I square both sides, we get 4y squared equals 4x squared minus 1. I add 1 to this and divide it by 4, and hence we get x squared. Perfect. Let's sub in that into our here. We get, so, well, what I can do is, yeah, I can take that 4 out, because it's a constant, and put it over here. Just write that. So 4y squared, so that's it. Is that it? Yes. And now, okay, let's just use basic integration. So 4 equals pi over 4. So it'll be 4y to the power 3 divided by 3 plus y. Oh, well, you don't want to write it y. We actually want to write it as h. Oh my god, we've kind of, yeah, your y values, just write it as dh here, sorry. Because your y value is just your height. And we want to write this as 4h squared. So writing this, we're just writing 4h to the power 3 over 3 plus h. And that's it. Plus c, but we don't worry about that in this kind of question. So volume. Because why do we know? Okay, think about it. Why don't we just add a plus c here? We know by basically the volume of the water at height 0. Like if you sub in 0, all in the heights, what happens? They just become 0. Like this whole becomes 0, hence your volume 0. And hence your c value is 0. Remember, we know that when height is 0 in here, there is no volume. That's, yeah. So we know that straight away that c is 0. So let's forget about that. And hence, subbing h and 0. So if I sub in h, I just get pi over 4. 4h to the power 3 over 3 plus h. And then, you know, if you sub in 0 minus 0, which is just going to be 0. So hence, we just got the form already. So nice and easy. That's not too bad. Find the depth h when the fountain is filled to half its volume, giving your answer in meters correct to 2 decimal places. Okay, so what's happening is that, let me just write this. So the max volume, we know the max volume occurs at this height, which is root 3 over 2, yeah? So imagine like drawing this fountain. So hence your max volume occurs at the height root 3 over 2. So let's actually calculate that max volume, because remember, we just want to halve that volume after. So let's calculate volume max. So what is the max volume? Well, the max volume is going to occur at, using this equation right over here. I don't want to use it. I'll use this to be safer. So if we're going from pi over 4, integral from 0 to root 3 on 2, is that right? Yep, root 3 on 2, the height. It's going to give me 4h squared, so 4h squared plus 1 dh. And that's going to give me my max volume, so let's do that in our CAS. Going over here and saying, what is the into pi over 4 times the integral from 0 root 3 over 2 4h squared plus 1 dh, and we get, okay, we get this right over here. But imagine, because this is your max volume, what we want is what depth does the volume at the volume of the fountain get, you know, halved. So imagine halving this, which is just times 0.5. We get root 3 pi over 8. So let's write that down. So here, this is pi over 4. And imagine, because that's your Vmax, and hence your half of volume, so half of the volume is going to be root 3 pi over 8. That's great. So just, again, using this whole formula again, so pi over 4, integral from 0 to some value of h, where the volume is actually halved and what height it occurs. So, and that's going to be 4 h squared plus 1 dh, and that should equal to root 3 pi over 8. And let's calculate the value of h. Let's do that. So, taking this whole thing here, putting h here, equals this. Let me solve. Answer, comma h. Hence, we get the h as two decimal places. So 0.59 meters. Nice. Let me kind of highlight that. Done. The fountain is initially empty, okay? A vertical jet of water in the center fills the fountain at a rate of 0.04 cubic meters per second. At the same time, water flows out from the bottom of the fountain at a rate of this cubic meters per second when the depth is h. Show that dh dt is that. Okay, so let's think. So we know that in the fountain, the rate at the water's coming in, we can see it's cubic per meter, meaning that cubic meters means volume over time. So it means that dv, pretty much dt, is 0.04. And that's going to be your in volume. Oh, sorry. That's going to be your in volume. That's what the water's coming in. Hence your dv dt out also, the water that's coming out, the rate at which it is coming out is what? It is 0.05 root h. Now we know that basic formula, guys, you should always know. When we have a rate in and a rate out, we know that the overall dv dt is going to be your dv dt in minus your dv dt out. Hence, that's what we want. We want the overall dv dt. So it's, again, so what we're going to do, this is just going to be 0.04 minus 0.05 root h, and that's it. Perfect. But we want dh dt. Let's think. So dh dt, what things can we do to get dh dt? Well, if we say have a height, dh dv times dv dt, why do you think I wrote that? So this is actually equal to that because, you know, those dv's cancel out. It's just dh dt. I wrote that because I put dv because I know already dv dt over here. So I needed just another part where I need to have a relationship between volume and height, which we already do, remember? Over here. Coming back to this, where volume and height is given by this formula. So let's actually calculate that. So going back to your original formula, going on our CAS, going back up. And well, like going back up to this and just writing h here, this is your formula. Perfect. This is volume. So now if I find the derivative in terms of height, of this, now we have dv dh, and what I want to do is to get what I want to get is dh dv, so it's just going to be the reciprocal of that, and we get this. So let's write that down, what we just did. So what I just did over here was, okay, I knew that the volume is, let me just go and look on top here. Okay, the volume is pi h 4h squared plus 3 divided by 12. And I found the derivative in terms of h, so dv dh, which gave me pi 4h squared plus 1 divided by 4. And remember, we want to find dh dv, so it's just the reciprocal of it. So dh dv is just 4 divided by, here, so 4 divided by pi 4h squared plus 1. And that's it. So taking this and subbing it into all these equations, so hence dh dt is going to be 4 times pi 4h squared plus 1 multiplied by dv dt. Now, okay, that's not too bad. So what I'm going to do is make this small. Okay, bring it over here. So dv dh, because it's in decimal places, what I can do is just go on my calculator and it will just simplify it and make it nicely. So for example, that 0.04 minus 0.05 root h, enter, and look at this. I also want to get it in a kind of a common denominator. Go on numbers, go to fraction tools, and go to common denominator of this. Perfect. This is what I'm going to use to make my simplification easier. So I'm going to do that. I'm going to multiply that by 4 minus 5 root h, all divided by 100. What can we see? We can cancel those out. It gets to 25. Hence, overall, we get 4 minus 5 root h, all divided by 25 pi 4h squared plus 1. And that's it. So same form as we've shown, and we've shown that nicely. Perfect. Find the rate in meters per second. Remember, meters means h, height over time. So dh dt. Great, we have the formula for that. So dh dt. So find the rate in meters per second. Correct 4 decimal places at which the depth is increasing. So when the depth is 0.25. So, okay, nice and easy. So we're just trying to find dh dt given that the height is 0.25. Easy. Let's do that in our CAS. So, all right. So I got this. Let me just do times this over here. And it gave us this beautiful equation. So this is your dh dt, and we just want to find, given that your height is 0.25, what is that rate? Control enter. And we want to 4 decimal places, so it will be, so down, so 0.0153 meters per second. That's it. Express the time taken for the depth to reach 0.25 meters as a definite integral and evaluate this integral correct to the nearest tenth of a second. So, okay, if we have dh dt, which is over here, I'm going to copy this. If we have dh dt, put it over here. I want to find the time. So if I kind of reciprocate that to get dt dh, so that'll be 25 pi 4h squared plus 1, all divided by 4 minus 5 root h. And if I can find the integral, so if I find the integral, I get t, the time integral, and these are your values of h. So again, we want to find the time at which it reaches 0.25. So we start, of course, at a height of 0, the depth of 0, and we want to get to 0.25 of this integral. So now I'm just going to copy it again and pretty much put it over here. dh, and that's it. Let's do that. So what we just did was I reciprocated this over here, and that gave me this. So I've got this now. I want to find the integral from 0 to 0.25 of this h. Enter, and we get we want to correct it the nearest tenth, so 9.8. And the time it will take is just 9.8 second. Done. So after 25 seconds, the depth has risen to 0.4 meters. Using Euler's method with a step size of 5 seconds, find the estimate of the depth 30 seconds after the fountain began to fill. Give your answers in meters corrected to decimal places. Nice and easy. So what we've given is, we've given our initial, so x0. Oh no, well, in terms of this, it's okay. We have time. So when time is 0, it is 25 seconds. And, well, your depth, your height, 0, is 0.4. And so we know that the step size, so your h value, is 5 seconds. And we want to estimate the depth at 30 seconds. Remember, so t1 is just 25, your it's just t0 plus your step size. So in this case, it would just be 25 plus 5, which is 30. And that's what we want to find, the h1, the height. Now, of course, you can use, Euler's method and stuff, but there's a quicker way using your CAS. And I want to show you that method because it's very helpful. So let's go to our CAS. And, okay, I want you to write Euler. Okay. And I want you to write the function, so the dH dt in this case, where if you go up, remember dH dt is the original, it's right over here. This is your dH dt, putting it in there. So we're going to put dH dt, comma, your t value, because remember, what is your independent variable? It's t. What's your dependent variable? So what's your y value? Well, we want to find, h's. Come on, we're going to put these scribble lines here. And what values of t are we going to? So we're starting from 25 and we're going to 30 seconds. Okay? Come on. And now what is, so at that initial, so t0, what is that height h0? It's 0.4. And hence, lastly, we just need to put the step size, which in this case is 5. Enter. Beautiful. This over here, what have I done? Have I made a mistake here? Yes, so this is perfect, yeah. So at 25 seconds, as you know, at t equals 0, which is 25, we get 0.5, which makes sense, h0. At t1, this is our h1. And that's it. You want to write this to 2 decimal places. Your h1 is just 0. To 2 decimal places, that would be 443. That's your answer. Now, of course, you can do it by hand, which is very also important to know because it could also be used. So by hand is very easy. You remember to get h1, it's just h0 plus your step size times your, in terms of this, it's dH dt. Given that h0 in this case was 0.4. So yeah, we can also show that. So again, so what is going to be 0.4 plus your h value. What's your dH dt? Which is, it's already here. I'm not writing that. So, but where h, we're gonna sub in where h is 0.4 divided by 25 pi for 0.4 squared, we're nearly there, plus 1, and that's it. That's overall. Yeah, writing this and it should give you the same answer anyway. So, pretty much, yeah. I hope that kind of helps you understand the question. Using a calculator is much quicker, by the way. F. Let's do F. How far from the top of the mountain, so top of the top of the fountain, does the water level ultimately stabilize? Give your answer in meters, corrected to decimal places. So what's happening is, okay, let's really look at this. So again, just kind of drawing this to make it look more understandable. So like this. This is your water fountain. So of course, as you know, what we're saying is, okay, imagine we're drawing where this here is your time and this is your h, height and time. And what we're saying is, when does the water level kind of stabilize? So of course, as time goes, as time increases, what happens is that also the height increases. So, because water's being filled in, water's being, put in. So your height will increase over time. So in other words, it looks like this. As time increases, your height's going to also increase. And it's going to go to a point that it's going to maximize. And at that maximum value, what do we know? It's going to look like a maximum point. It's going to be a maximum point. Hence, to find that maximum point at which, do we want t, actually the value of time? Or the how far? Yeah, so in other words, we just want to calculate the value of h for which the maximum occurs. In other words, where dh dt equals 0, that height at which that maximum occurs. And yeah, so imagine that maximum's over here, but remember we want from the top of the fountain. So it'll be this over here minus this, the point. So yeah, I hope that makes a little much sense. Again, so this is your maximum point. Imagine that height's there, so we just need to find this height. Okay, going back to this question. So we want dt to be 0. So we want this to be 0. So let's write that down. dh dt is 0, where 4 minus 5 root h, and if you let it equal 0, this cancel all out. It'll just be that equals 0. And because we want to, we can actually calculate the height. Hence your height is just, let's just use our calculator. So like, solve 4 minus 5 root h equals 0, comma h. So this is your h value. And remember, where we want from the top of the mountain. So from the top of the fountain, root 3/2 minus this value over here. And to correct to 2 decimal places. So from the top of the mountain, what will also give you an answer in meters, correct to 2 decimal places. That will be just height is 0.23. That's your height at which the water stabilizes, meters. Have I done anything here wrong? Looks good. Great. Next question, question 4. 2 yachts, A and B, are competing in a race and their position vectors are, so on a certain section of race after T are given by this, so this RA and RB, these are your position vectors, where T is greater or equal to 0. Where displacement components are measured in kilometers from a given reference, I don't know, that's like at origin, so that's at the origin. Find the Cartesian equation of the path for each yacht. Okay, not too bad. So for your I, this is your x component, so your I is your x component, so it'll be x is equal to t plus 1. And your y will be this. It's your j component, so it'll be just t squared plus 2t. Now here, I can calculate the value of t. It will just be x minus 1. And I just sub this into this. So hence, it's going to be y, x minus 1 squared plus 2 x minus 1. And so overall equation of A is just, if I simplify this, x squared. Actually, let me take a common factor of x minus 1. It will just be x minus 1 plus 2. Yeah. Why am I making my life harder? What am I doing? No, that's not even good. Just let me expand the whole thing. So it would just be, let's be safe with it and just expand the whole thing. So, x squared minus 2x plus 1 plus 2x minus 2. Y is equal to x squared. Those cancel out. 1 minus 2, which is negative 1. Hence, this is for your A. This is for A. This is A. For B, same thing. So your x component is just t squared, and your y component is just t squared plus 3. Hence, we know x is equal to t squared, so let's sub that in. So just y equals, if we know t squared is just x, so it would just be x plus 3. That is your equation. Done. Next question. Show that the 2 yachts will not collide if they follow these paths. Okay, so they're following these paths. Great. So if they don't collide, we want their positions. So to show, do these positions, for example, the position of A vector should equal to the position of B vector. So what we're saying is, when is the I and J components equal to each other? And we'll calculate those values of time. If the times are pretty much, if both times are actually equal, it means they do crash, they do collide. But for example, let's look at this. So if I had A and B here, so let's say, think about it. So let's say this is boat A, and let's say boat B is on top of it. Now, of course, the I and J components will be, these over here will be equal, of course, but it does not depend on that. For example, the times have to be equal. It means if the times are equal and the positions are equal, it means they did collide. For example, let's say in a second, in one in 1 second, A is over here, and at the let's say at the third second, B is here. Can you see how they're still at the same position? So this will equate to it, but we want to make sure the times, if the times are at equal, it means they do collide at the same time. So that's the way we would want to show. So okay, what's RA of t and RB of t? So equating those, so saying, so I and J components. So we pretty much so this I to this I, we're gonna so t plus 1 t squared, and the other one is going to be t squared plus 2t equals t squared plus 3. So I'm just going to pretty much use my CAS just to calculate these values of t and see if those values are equal. So for the first one, it's just going to be solve t plus 1 equals t squared, comma t. Hence we get two values, but of course t must be greater than 0, so we're going to take this. For the other one, solve t squared plus 2t equals t squared plus 3, comma t. And we get t equals 3 over 2. Let's write those down. For this one, t is equal to root 5 plus 1 divided by 2. And this one, t equals 3 over 2. Can you see how the times are different? It means they don't collide, actually. Hence, yeah, we've actually shown t, we can say that t of A, this is t of A, and this is t of B. T of A is not equal to t of B. Hence, we've just shown that they are not equal, those values, so they don't collide. C, find the coordinates of the points where the paths of the two yards, cross. Give your answer correct to 3 decimal places. So we want to find the coordinates. So it'll be the best to use these over here because these will give us x and y. So I think because it's just, yeah, what we can do is, if I know, let's write that down. So y equals x squared minus 1. Is that? Yep. And the other one's going to be y equals x plus 3. So what I'm going to do is I'm going to pretty much sub this in here. I'll actually equate them. So just x squared minus 1, x plus 3, x squared minus x, minus 4 equals 0. And I'm going to solve for that. I'm going to solve for these values of x. But be careful, actually. We didn't consider the domain. We need to actually consider also the domain. Remember, okay, what is the domain? Well, that's only for t. Of course, t is going to be greater or equal to 0. But let's have a look at this. If I take this over here, t plus 1, x is equal to t plus 1. We know if we calculate the value of t, it's just x minus 1 equals t. And remember, t is greater or equal to 0. So if I sub t, because we know t is greater or equal to 0, what is this? Greater or equal to 0? Because that's equal to t, hence just x is greater or equal to 1. That is your domain. So that is very important. So we need to also make sure when we're finding solutions, we want x to be greater or equal to 1. Let's do that using our CAS. So what you pretty much want to do is we want to solve for x squared minus x minus 4 equals 0, comma x, given that x must be greater or equal to 1. Enter. And we get a value, but we want to 3 decimal places. But we also want the coordinates. So we know that y equals x plus 3. So it's this here, plus 3. That is your y coordinate. So this is your x, and this is your y coordinates. Let's write those down. That's where the 2 yards cross. To 3 decimal places, that would be 2.562. And the next one will be 5.562. Is that right? Yeah, they look good. So, great. Next question. One of the rules for the race is that the yachts are not allowed to be within 0.2 kilometers of each other. If this occurs, there is a time penalty for the yacht that is traveling faster. For what values of t is yacht A traveling faster than yacht B? So we want to find where yacht A is traveling faster. Okay. So, okay. We know that the speed, so we want the speed of A to be greater than the speed of B. So remember, speed, so if we find the derivative of the position, it's going to give us our velocity. So we want r of t, but this is velocity. We want to make sure we find that magnitude of it. It means now it's speed. So we want the speed of A to be greater, to be traveling faster, to be pretty much traveling faster than the magnitude of the speed of B. And it says what values of t. And given, we also want to make sure that t is greater or equal to 0 because we're dealing with time. So let's do that. So in other words, I haven't actually defined them. So let me just define them because it'll make calculations much easier. So r of a, if I go up here, r of a is just t plus 1 t squared, oops, t squared plus 2t. Have we done everything right here? Yes. What about RB of t? So it's just going to be t squared plus 3. Enter, and that's it. So again, so we want to find, okay, those. So we want to find the derivative in terms of t of first r of a of t. So this is going to give us our velocity, but we remember finding the norm gives us the magnitude. So norm of this, so now we have the speed of this must be greater than, pretty much copy this, the speed of B. Given, just let's press enter first and then we solve. Answer comma t, given that t must be greater or equal to 0. Enter, and we get t is between 0 to 5 over 2. Let's write that down. That's your answer. So t is between 5 over 2 so equal to 0. That's your answer, but because it's too much, we do want to show working out. So in other words, let's write this equation here, the simplified version, all of it. Oops, that's not it. So we said, 4t, this is whatever we write in our cast. What's it done? 8t plus 5. We say it must be greater than 2 root 2 absolute value of t. And yeah, pretty much that's it. I think this will even give you the mark. You've shown what your thought process was. You've given the answer. You've also shown some working out. So that's great. E. If yacht A does not alter its course, for what period of time will yacht A be within 0.2 kilometers of yacht B? So what we want to find the time interval. So this is yacht A. And wait, if yacht A does not alter its course, for what period of time will yacht A... Oh, actually, the opposite kind of. Yeah, so imagine this is yacht B here. And this is yacht A. And at what period, there will be a period that yacht A is traveling faster than B, and the distance between them will be approximately, 0.2. 0.2, but we want it to be less. It will be less than 0.2. And that will be where, what the question is telling you. If yacht A does not alter its course, for what period of time will yacht A be within, so less than 0.2? It could be 0.1. It's, within that 0.2 kilometers of yacht B. And yeah, that's what we want. We want that. To do that, it's quite easy. In any case, you can just say, because he says, if A doesn't want to scale, what period will yacht A be within? So what we can just say is the RA, so the position of RA of t, so the position of RA of t minus the position or RB of t, so it means that distance, this distance. Well, it's not distance. To make sure it's distance, we're going to put the absolute values. We have to make sure. So the distance between RA, so the boat of A and B, must be, we want to find the values where it's less than 0.2 pretty much. Is that right? If so if yard A does not alter its course, for what period of time will yard A be within that 0.2 kilometers of yard B? So this will give us that. I mean, also the same case, you can, by the way, if you're confused, you can just put RB of T minus R of T, same thing, you should, because we're putting the absolute value. So let's do that in our CAS. So what we're trying to solve is solve absolute value, or because we did vector, norms of RA of T minus RB of T. So the norm of this must be less than 0.2, okay, comma T, given that T must be greater or equal to 0. Control enter, and we get the value. So that's great. It's so the time period that at which they are within that 0.2 is this over here, from this to that. So let's write that. Well, let's find the actual time difference. So it'll be this minus this, and time, it gives us this in hours, but remember it wants it in minutes, so we're going to multiply this by 60. Control enter, and we get this. So let's write what we just did down. So we solved that, and we got 1.528831 less T less 1.597336. Hence, your values of T, the time at which occur is 4.1 minutes. Great. Question 5. Luggage at an airport is delivered to its owners through a 15-meter ramp. Okay, so this ramp over here, from here to here, pretty much is 15 meters. That is inclined at 30 degrees to the horizontal. A 20-kilogram suitcase, initially at rest at the top of the ramp, slides down a ramp against resistance of V newtons per kilograms, where V meters per second is the speed of the suitcase. On the diagram below, show all the forces acting on the suitcase during its motion. So, of course, we're going to have a gravitational force down, and that's going to be 20 Gs. We're going to have also a normal reaction force. And remember, there is friction force. So make sure you put that friction over here. That's going to be opposing that motion. But be careful. Here it says that V is newtons per kilogram. So this V, velocity, is newtons per kilogram. Remember, force equals mass times acceleration. In other words, what it's saying that it's acceleration in a way, because newtons per kilogram, force is newtons, mass is kilograms, acceleration is meters per second, just call it A. If you divide to get A, we just get A is newtons per kilogram. Hence, this is in the units of newtons per kilogram. Hence, this V is pretty much your acceleration. Be careful. This is a lot of students might make the mistake. This is your acceleration. Hence, to find that, what do we call it? To find the force, remember, force is equal to mass times acceleration. We know that acceleration is V. It's just V times mass. And the mass is 20, so it will be just 20 V. That is it. Have I made any mistakes? So on the diagram, show all the forces. We got downwards, this and that. Yeah, that looks all it. By resolving the forces parallel to the ramp, write down an equation of motion for the 20-kilogram suitcase. Not too bad. So of course, we're going to kind of break this down, this over here. And we're going to get downwards here. Because we're saying that the acceleration is going this way. It's accelerating down the ramp. This part over here, it's going to be 20 G sine 30 degrees. Hence, we can say, by resolving it, because this one's going to be positive, because it's going in the direction of the acceleration, so it'll be 20 G sine 30 degrees minus this 20V. Remember, they are kind of parallel, to the ramp. Minus, but it's in the opposite direction. 20V must equal to your mass times your acceleration. What's your mass? It's 20 times your acceleration, A. By resolving parallel to the vector, write down an appropriate equation of motion. Yes, we've done that. Yeah, is that it? Do we... by resolving the forces parallel to the ramp, write down an equation motion for the 20 kilogram suitcase. And we've done that. Great. Hence, show that the magnitude of the acceleration of the suitcase down the ramp is given by this. Okay, we just need to calculate A, it means. Just calculate A. So, we can cancel the 20s because all of them have 20s. So, we can write this as G. So, sine 30 is sine pi over 6, which is just, so, sine 30 degrees is sine pi over, which is half, minus 20v, minus v, we took the 20s, minus equals A. Hence, A is equal to that, which is just G over 2 minus V equals A. Hence, your final is just G minus 2V over 2. That is your answer. Nice and easy. Yeah, looks good. By expressing A in an appropriate form, find the distance x meters that the suitcase has slid as a function of V. Give your answer in this. So we want a suitable thing. So we luckily, okay, we know for acceleration here, going back, is G minus 2V over 2. We know by acceleration, we want in terms of x and v. X and v. Now, if you look at your formula sheet, you know that acceleration can also be written as v dv dx. That is acceleration. So using this and subbing it into A, the acceleration, what do we get? So we get v dv dx is equal to g minus 2v over 2. Let's wrap that out. Okay. We're going to divide v by both sides, so it'll be dv dx. So if I divide these, we just get 2 minus 2v divided by 2v. And kind of reciprocate it, so we get dx dv 2v g minus 2v. Okay. And if I find the integral, we get it in terms of x and v. But be careful, we want to make sure we get it in this form. What do we see? Well, v is by itself. In this case, we want v to be by itself because what I think is, okay, if I can take a common factor of 2 from the bottom, for example, if I get 2 common factor, it will be just g minus 2 minus v. So that's nicer in the long term. And we can cancel those v's out, actually, too. That's good. So, just oops. These v's, these cancel out. Great. So, what we do next is, okay, we can actually, like, we can actually simplify that by, normally you can, divide it. So let's do that. Let's use our CAS to be 100% sure. So dx dt, dv. Let's go use our CAS. So we just want to go to expand. You want to make sure it's in like partial fractions form. So v g over 2 minus v. And we get this. So let's write that down. Minus g over 2v. No, we don't want to do that. Because now we're back to 2v. No, we don't want that. I think, let's do it by hand, actually. Let's just 100% do it by hand. So what we're saying is v plus 0 and minus v plus g over 2. We're dividing it. If we put a minus 1 here, it'll be v minus g over 2. Hence, it will just be overall minus 1 plus g over 2 divided by g over 2 minus v, pretty much. Yes, so that's great. So we're nearly doing well now. And then we need to find out it's just the integral of that. So integrating -1 plus g over 2 divided by g over 2 minus v dv. Hence, x is what? It will just be negative v, so it'll be negative v. If I integrate this here, what do we get? So g over 2, we can take it out. It will just become 1 over g over 2 minus v. So when we integrate that, that will be a negative, and there'll be a log e absolute value g over 2 minus v. Let's write that down. So it'll just be my g over 2 log E G over 2 minus V. Okay. And then we're also going to plus C. Now, the question did tell us that initially the velocity is 0. So the distance would be 0. Imagine, like, initially, we haven't even gone any distance. So x is 0 and v is 0. So when x is 0, that's your initial condition. So that's 0. That's 0. And it'll be just negative 2 log E. That'll be just g over 2. The absolute values cancel out because it's a positive value. Plus c. Hence, just your c value is this. So we can write that down here. G over 2 log E G over 2. All right, we are nearly done. Okay, because we got these both have the sign like G over 2, what we can do is we can rewrite this, putting them together, so negative V, it just become plus G over 2 log E, so that, so G over 2, okay, wait. Let's look at this, so, what can we do here? Why is my brain freezing? Oh my god, it's very easy, but okay, so we can, okay, yes, so plus G over 2, then if I take G over 2, so G over 2, are we looking at this? So it'll be G over 2, yes, so we hence log E G over 2 divided by G over 2 minus V. I'm going to take the absolute value. I don't think we need those anyway. There we go. We should just simplify those because these, we just simplified those. They had both log and they had G over 2. Pretty much that's it. Is that right? X is equal to B, V, which B is negative 1. C is G over 2. Yes, C is also G over 2. And yes, this looks good. Now, I think that's it. That's your answer in that form. Oops. Wow, that took very, very long. Damn, that's all right. Next question. Find the velocity of the suitcase just before it reaches the end of the ramp. Give your answer. Okay, so when it reaches the end of the ramp, it's 25 meters. We know that x is 25 meters. So we just want to find that velocity. Very, very nice. Just use your calculator. So we know that x is going to be 25 equals, writing the whole equation, minus v plus. Now, make sure for the g's, you put 9.8. So like 9.8 over 2, natural log. Pretty much, I'm going to copy this and say that it's on top, that's on minus v. And you want to solve answer, comma, v. Hence, we get two v values. Of course, v is going to be positive. We should have thought about it because remember we are going down the ramp and we took acceleration down to be positive. So hence, your velocity in that direction has to be positive. So it has to only be this. So to 2 decimal places, that will be, velocity is 4.89 meters per second. Done. Write down a definite integral that gives the time taken for the suitcase to reach the speed of 4.5. All right. That's not too bad because, look, we know this acceleration formula here. Let's use a different color. So let's write it down. There's many ways you can write the acceleration formula to your 8. So minus 2v over 2. I know that acceleration can also be written as the rate of change in velocity over time. So dv dt, we can write it as g minus 2v over 2. And imagine reciprocating that. dt dv is 2 over g minus 2v. Hence, time, the integral that we want, will be the well, write that integral that gives the time. Okay, so yeah, so hence the integral, because time will be, we're starting with a velocity of 0, it tells us, and we're going to go to a velocity of 4.5, and writing this whole thing, dv. That is your equation. Nice. It's only 1 mark, so I think I'm just going to rub these out because it's pretty much making it too confusing. And here is your formula. That's it. Next question. Pretty much find the time taken for the sucker to reach that speed to second. Okay, that's easy. Just evaluate it. So we're going from 0 to 4.5 2 over, which is G is 9.8 minus 2V, and that gives us two decimal places, 2.51 seconds. That's it. Question 6. Yes, probability. The heights of mature water buffaloes in northern Australia are known to be normally distributed with a standard deviation of 15 centimeters. It is claimed that the mean height of the water buffaloes is 150. So that's, okay, claim. To decide whether the claim about the mean height is true, rangers selected a random of 50 mature water buffaloes. The mean height of this sample was found to be 145. So it's less than, so we got a sample mean, which is 145, and now it's less than the actual, standard mean. So we're probably going to do a statistical test. Yep, a one statistical test is to be carried out to see if the sample mean height of 145 centimeter differs significantly from the claimed population mean of 150. Let the sample mean denote that the mean height of the random of 50 mature water buffaloes. State a suitable hypothesis. Okay, so the null hypothesis and the alternate hypothesis. Very easy. So the null hypothesis is what we're saying is where there's no change. It's the original, which is just 150. And the alternative hypothesis, now we're saying, is that it's less than, because it's 145, so it'd be where the alternative hypothesis is where the mean is less than 150. It's actually that 145. So that's what we're going to be carrying out. Say the standard deviation of x. Sample mean, that's easy. So standard deviation of the sample mean is just the standard s over root n. In this case, what's our s value? It's just that 15. So it'll be s 15 over n. In this case was 50 mature buffaloes. So that's your n value. And here, kind of go on our calculator and just simplify that. 15 over root 50. And that gives you 3 root 2 over 2. They don't want it in decimals, so yeah. Write down an expression for the p-value of the statistical test and evaluate the answer correct to 4 decimal places. Very nice. So your p-value in this case would be the probability that the sample mean is less or equal to that, where is it? What, 145? Given that your mean, your null hypothesis, which is just 150, we want to find that. Very easy. So hence your probability is just going to be, we denote as z. Pretty much transform it back to the normal distribution. So it'll be just 145 minus 150 divided by this over here. 3 root 2 over 2. And now let's use our calculator to calculate our p-value. All right, so what we just got was, okay, -5 on top, so 140, yep. And this over here would be this. Control Enter, and we get this value. Hence, what? Let me just copy it again. Okay, so go on menu, probability distributions, normal CDF, and because we want per bound to be this, now we're using the standard normal distribution. Hence, these your mean is 0 and your standard deviation is 1. You press Enter, and we get the value, your p-value. Let's write that down. To what? 4 decimal places, so 0.0092. That's your p-value. Stay with reason whether the null hypothesis should be rejected to 5% level of confidence. This is how you know. If the p-value is less than your alpha, which is, that's 0.05, then we reject the null hypothesis. If the p-value is greater than 0.05, then we accept the null hypothesis. These are the things that you only need. For in this case, let's have a really look at this. We can see that the p-value is less than 0.05. It's very, very small, actually. So hence, what do we say? If p is less than 0.05, we reject the null hypothesis. Yeah, pretty much that's it. Stay with a reason. We've the null hypothesis should be rejected at 11%. We know that the p-value is less than 0, reject. Done. what is the smallest value of the sample mean that could be observed for these null hypothesis to be not rejected? Give your answer. So, okay, what we just did here is, okay, for what value of sample, so imagine like, okay, in other words, what we're saying is the probability, like imagine we're trying to find the probability that your sample mean is less or equal to some sample mean, like x. What am I doing? Wait, what am I doing? Okay, let's think about this actually slowly. What is the smallest value of the sample mean height that could be observed for the null hypothesis to not rejected? Okay, if we want the null hypothesis to be not rejected, we need the p-value to be greater than 0.05. Yes. So, in other words, what we're going to say is less or equal to some value of x. That's your sample mean in this case. Given that it's still 150, and that overall we want it to be, because we want the smallest value, it has to be 0.05. Pretty much what we're doing is we're solving for this, which is just going to be the probability of z less or equal to some x minus 150 over 3 root 2 over 2. That all is equal to 0.05. Let's simplify this. So we just go to menu and just go to probability, distributions, inverse norm. Well, the area is 0.05. Press OK, we get this. So that should equal to x minus 150 divided by, actually just go to the top, this over here. Enter. When we just want to solve, enter, comma, x. And so x, so your sample mean should be, for us to have this, for it to be not rejected, we need to have, to 2 decimal places, that'll be 146.51. That's it. If the true mean height of all mature water buffaloes in the Northern Australia is in fact 145, so now our actual mean value is 145, it's saying, what is the probability that the null hypothesis will be accepted at 5 level percent significance? Give your answer correct to 2 decimal places. Okay, remember, for it to be accepted, again, it must be greater than that 0.05. And so what we just want to find is the probability. Wait, if the true mean height of all, we want the p-value, so hence we can just say, yeah, the p-value or the probability. Wait, if the true mean height of all mature is in fact 145, what is the probability that h will be accepted? Will be accepted, okay. So what we want is, in this case, we know that your sample mean, we want it to be greater or equal to this over here, that 146 over here, so 146.51, and our normal mean is 145 because now that's changed, and we want that overall, yeah, to, wait, if the true mean of all mature is in that, oh my god, that's actually, wait, if the true mean height of all if the true mean height of all mature water buffaloes in the Northern Australia is in fact 145 centimeters, what is the probability that the null hypothesis will be accepted at a 5% level of significance? Give your answer. No. Take that to be less or equal. So your sample mean must be less or equal to 146.5. We're using that sample mean. And for it to be, what is the probability? Yeah, pretty much that is it. Is that right? No. Sorry, it must be greater or equal to that value. Yeah. Let's try to calculate that and see what happens. I don't know what's happening with me. Wait, so we can write that as probability that z is greater or equal to 146.151 minus 145 divided by our still value, which is 3 root 2 over 2. And what's that overall? So we're saying this over here, oops, oopsies, this over here minus 145 divided by this over here, and that gives me this here. And what I want is the probability, this, where this value goes to infinity. Press OK, nothing again. So actually wait, this value goes to so this goes to infinity. I'll write in the whole expression, yes. Okay, and we get this. Hence, it's, yeah, so is this your probability? 0.24. Wait, I need to actually, wait, we need to understand what they mean. If the true mean value of all the mature water buffaloes in the Northern Australia is in fact 145 centimeters, what is the probability that the null hypothesis will be accepted at 5% level of significance? Okay, yeah. So we want that to be greater or equal to 146.5, given that, okay. Yeah, looks good. Looks good. That's, yeah. Wow, I don't know what happened now. Did I just get like... my brain died right there. G, using the observed sample mean of the 145 centimeters, find a 99% confidence interval for the mean height of all mature water buffaloes in Northern Australia. Express your values in the confidence interval. Nice and easy. So what we do, you can do this in the calculator. Go and probably stats. Go to confidence intervals. Go to Z interval. And we want stats. Okay. Now be careful. This is not your mean or the sample mean. It's the mean of the original. So going up, the mean is 15 actually. So, and your sample mean is what? 145 in this case. We also know that N there is 50, and also we want 99%. Pressing all that, Control Enter, we get these values over here. So, but the question tells us to 1 decimal place. So, just writing those. 139.5, 150.5, and that's it. And that's the end of the exam, guys. Thank you guys for watching. I hope you learned something through this video. Please make sure to like and subscribe to for more future videos, and please share this video with your friends. I hope you guys have a great day and take care of yourselves. Bye bye.